supervisor Duncan Kim. The paper entitled with hierarchical and hash-based naming scheme for vehicular information-centric networks is basically emphasizing on information-centric networks. Currently, we have the IP-based or host-centric networks going on, and mostly, even in this conference, we have some valuable contributions towards the IP-based networks. I think a couple of papers are dealing with the future internet. Basically, ICN is one of the future internet technologies we are expecting to be there. So the agenda of my presentation today will be introduction to a little bit introduction to ICN, and then I'm gonna talk about how we can integrate ICN into VANETs or in the vehicular environment. And then we will have a look about naming schemes. What is naming? I'm explaining in the coming slides. And this is the special key term used in ICN, if anybody will have some information on that. And then we have proposed our naming scheme, the basic naming scheme. It is just an overview, but it has different pros and cons, of course. And then I'm just going to show the extension of this proposed scheme in one slide that we have already submitted to the Journal of Networks and Computer Applications, but I'm just going to show the results in one slide. And then, of course, conclusion and future work. Well, what we have today in networking, we have the device-centric approach. What does it mean is that whenever we want to send a packet or if we need some data, so first we depend on the address of that device using IP or DNS servers and different kinds, but we are completely depending on the device and we need to locate that device. And also most of the communication is being done by addressing that particular device. Maybe it can be a destination or a relay or some other things. Then more than 90% of the traffic is accessing different kind of data. Basically, why we need communication or why we need even network? Because we need data. But currently, to be honest, in the host-centric or IP-centric networks, most of the time is being spent on identifying the providers or identifying different devices instead of identifying the data. That's what we are doing currently. So, of course, that kind of approach can be insufficient for content or data dissemination in any environment, not only in VANETs or in any environment. In multicast environments, usually we have a huge cost of network resources. Here, network resource means that we have multiple IP addresses and DNS server authentication, association, and different things with different problems, multicast especially. And when we talk about addressing, so DNS, IP version 6, of course IP version 6 is a part of future of internet, but there will be definitely pros and cons in that as well. And most of the time we will identify devices. So we will tackle this problem by, maybe we can tackle this problem by introducing the information-centric networks. And then the other problem we have in service discovery that we do have many protocols, but there are no standards, very few standards are there. The main two problems which ICN is made for is to tackle the mobility. Even though mobility is achievable by the current IP-centric or host-centric networks as well, but it's not inherent in today's or in future's network. I will show you in the next slide how. And the second main problem is about security. We are securing the connection. We are not securing the content. That is a problem. We have IP security, VPN, SSLs, and but no content security. So what is the result? Still we get spam in shape of data or something. We do have a secure connection, for example, with this person sitting right in front of me, but I don't know whether the data is secured or not. So to tackle these kind of problems, we have been given a chance to work on ICN. Before going to ICN, I'm going to just show you some statistics collected by the Cisco very recently in 2014, I guess in June or somewhere, just like 3 to 4 months ago. According to them, the mobile network, what will be the position of mobile network through 2018 in the next couple of years? Many global mobile data traffic will move on or move forward than more than 15 exabyte. And maybe you can find out the detail what is exabyte. It contains 1,000 petabytes, and 1 petabyte contains 1000 terabyte and 1 terabyte. We all know that thing. So, but anyway, the purpose is to just see, to just look forward that how much data we are going to move between in coming few years. Then the number of mobile connected devices will exceed the world's population by 2014. So that's where we are right now. And the average mobile connection speed will also surpass 2 megabytes per second, just maybe after 2 years. So the main reason of showing these statistics are that throughout, if you look into these statistics, we are not talking about the devices. We are talking about the data. How much data will be generated, received, sent, or traveling between the devices, different devices. It contains managed, laptops, cell phones, well, anything. So basically, we are now talking about the data. Nobody's talking about devices in this whole survey. So just to give you a little bit glance of this thing. Communication of huge amount of data or contents with addressed devices. Okay, now let's come back to the topic of ICN. What is ICN and how it tackles the problems which I have stated in my first slide? ICN represents the third revolution in telecommunication networks. It was presented first, and I guess, if I'm not wrong, in 2008 by Van Jacobson. He is basically one of the founder or innovator of this idea that we can address the name, or we can give the name to content instead of giving name to different devices. So basically, information, content, or data, they are the center of networking, not the nodes or machines. That's the main concept. So we need to name some data. For example, if I need a data in current networks, I'm talking about current networks. If I need the data, any data that can be XYZ, so I have to broadcast the message, or I should know that what is the address of different nodes available in this room. I should know the address, I should know the route, I should make the path or everything. And after that, making the path and making the preparing the routing tables, then I can find that XYZ data which I'm looking for. But an information-centric network, I don't care about who is the provider. I only care about my data. I will name the data, I need it. I need XYZ. Maybe the first node I encounter with has that data, or maybe the last node I will encounter after some time, it has the data. So I don't care about the connection security, and I don't care about the person who is giving me. I do care about the data from where I'm getting. So that is the main concept of, or overview of the ICN. Same thing is elaborated in this slide as well, that we should name data and not the location. We should request data in the network. We should not find out the data provider. We should not find out the host. And also any node with the data or a copy in its cache memory, which I will explain later that what is cache or what is memory. They should just respond to the request. They should not respond to me. After, for example, if this person receives a request for data XYZ, so we should not concern about that who is sending this request. He should just directly respond to that request, and that's it. That's his task. It will definitely the delay will be minimized by adopting this kind of nature, and we will have more security because, again, we do take care of our data. But in ICN, mostly it's pull-based. Pull-based means the consumer or the requester should generate some interest, should show some interest in the data. Otherwise, if I have some data and if I'm receiving no request for that data, I don't need to disseminate that periodically, which is usually happening in current minutes. If I have something, I have a traffic information, I have a weather information, I usually disseminate that thing. But why? Why am I using the bandwidth and why am I using the extra space in the network congestion? I should keep that thing with me. If somebody wants that can just request and then I can respond, that's it. But I don't care about the identities of that information, that's all. Broadcast the interest packet, wait for the data packet, that is the main thing. Anyway, in ICN, what are the main or the basic operational perspectives? This slide shows that thing. In ICN, basically we have three things which each node will have to take care of or will maintain in terms of data structures. The very first thing is CS. CS stands for content store. And then the second thing is PIT or PIT, which means pending interest table. And then we have FID, that's not FBI for sure, it's FID, forward information base. So in content store, we cache the contents. Now, what means here, if I am a generator of something, if I have a data generated by myself, I'm the creator of that data. I'm passing by some road and I found some accident happened there. Or maybe I received any kind of data over there, data from traffic congestion on the road or something. That will be stored in my content store. Because we believe that in vehicular networks or in the wire networks or anywhere, we have a lot of memory, so we can just store the content stores. Then we have PIT, or pending interest table. This table will be having interest names, which I mentioned before, that we should name the data. So in interest, we will include the names of that data, which we're looking for, or which we have to forward, or which we have that data in our content store. So the table with interest names and their received faces and or interfaces. Now, why I included these two names, faces and interfaces, because in most of the ICM papers, these two terminologies are being used alternatively. So just to avoid the confusion, faces or interfaces. And then we are, which are of course in pending, it shows that they are pending, so they still need to be satisfied. And what kind of information we have in FIB or forward information base? It contains names, prefixes, and with outgoing interfaces, which means that if, for example, I have been selected as a relay, or I'm a relay between the consumer and the provider, so it means I should maintain my FIB as well. I will show how it works. Any node that receives interest message, that's I'm giving an example of myself. Search in my CS. I should search, first of all, that data in my content store. If I find, I can just respond back to the consumer await data. Otherwise, I should forward that response. 5 minutes I have? Okay, just very fast. Anyway, okay, so that's how it works. Anyway, that's how the, I'm sorry, so there you can see that we have different routing tables, and we have FIB, we have CS. Basically, when this is a subscriber, or what I said is consumer, it is sending the request to this node, because currently this node is in the transmission range or approximate range. So we have made a different shape of these things just to make them clear that they are the relays, the content relays or the content requester. So each node will basically, I'm not sure this thing is not working, but anyway, each node will maintain these routing tables. So here you can see that first after receiving the request, this node is going to search the CS. If the name is not there, name there means the content name. If the name is not there, it's going to search into the PIT, which means in the pending interest table. If this node has already forwarded the same request, so it means that, for example, because we will have a periodical dissemination of interest. So if it has already forwarded the same interest, it means it will not forward again or not rebroadcast again. Otherwise, it will rebroadcast that to, it will just check the FIB data structure. And you can see that in FIB data structure, it will just match the name. It's not very clear here because the interface is a little bit bigger than expected. But you can see that name has different attributes. So it will search each attribute line by line. And after searching that, in the FIB, if it finds that it has already forwarded such kind of information of the name data, so it will forward to that node. Otherwise, it will broadcast to all of them. In this case, you can see that this is AUEV. I'm sure you cannot read it, but I'm just trying to explain for you guys. It's AUEV.gr/KL/ blah things. So now in CS, this node didn't find the node. So what it did, it did check it in the PIT. In PIT, there was no name, so it included the entry that now it's going to rebroadcast the interest. And now in FIB, it checked that whether it has already broadcasted this interest or not. So it found that we have AUB.gr/ and then AUB.gr/CS. But here it's after slash, it's AL. So it means it's not to be forwarded to B part. It should be forwarded to C part if there is a possibility. So now it will forward to C, and C is connected to publisher. So that's how they will get connected. Instead of just trying to, you can see that there is no ID for subscriber, no ID information required. It will just broadcast the interest and that's it, and wait for the data. The same concept, this was the concept in the wired network, and the same concept was adopted in vehicular networks as well, where we have highly dynamic topologies and unpredictable link lifetime and same different challenges which we all know already. So I have to speed up the presentation. I will skip this slide. We know that they are with and without infrastructure, and the data ranges from short messages to, it can be for the large video message as well. Now what is VICN, Vehicular Information Centric Network? How to name each content in vehicular network. Because, of course, when we name data, it means we should have some standard. But still, because the field is very new, it is just started, the research in vehicular ICN has been started back in like 2010 or 2011. So still we do not have a standard to name a data. So researchers are playing around with that thing. Maintaining names, especially in PIT and FIB, requires attention from the research community. Because of course we will have thousands of names. So how to manage them, how to delete them, how to add them, and then how to search them. We should have new searching algorithms. So that's how we should find out how to name each content in vehicular network. And for example, to maintain those names in PIT and FIB, especially data structures with minimum space, fast addition and deletion and all that. So for that reason, we have several approaches available, like 3 approaches or 4 approaches available in the literature, research literature. The one is known as a flat naming scheme, which has like 256-bit long name with some hash function in it. We have the hierarchical, and then we have attribute-based, and then we have hybrid-based naming schemes. But all of the schemes have pros and cons. Due to the limited time, I will skip that, but for references, I have included these 4 papers you can see in this slide. And we have why we need those names and why we need to have such strategies, because we should forward those names into the network. So we should have some standard name for some data. And also segmentation and reassembling of those names in our PITs and FIBs are also required. Different architectures for ICN have been proposed, so we have different naming schemes. What we have done here, this is the main one slide. I will just take 1 minute of that. We are basically dividing the name into prefix. Also, we have the hierarchical section as well, where you can see that there is some information regarding the owner. Owner here means the one who has the data. So we call it the publisher or the owner or something. So we have the owner information here as well, and then the content information. That's it. But it is included in the name of the content at the provider side or at the publisher side. Now, what we are doing here, we are going to generate one hash function by the last part of the name, which will be unique on the basis of attribute of each file. If it's a .dpi file or .jpeg file or .text file or any file, and on the basis of contents in those files, we all know that what the hash function is exactly. So hash function, it will be unique for every file. So we can use the hash function to identify the content instead of the whole content name. Of course, for searching algorithms, you can imagine that if I start searching or matching the whole content name, it will take a lot of time. So instead of doing that, we can just identify by using the hash function system. And this is the extension. Graphs are a little bit horrible to understand here, to make it understandable here, but we have just performed some extension and we performed some experiments on our another proposed scheme which already submitted to evaluation in a journal, which is compact triad structure. So we basically extended this previous work. Here we just presented the overview of our naming scheme, and we extended our previous work with the name prefixes. For example, if this is the name prefix, VICN, some place in the US, California, and then we have some other name, for example, some image. So how we can compactly, how we can apply some triad structure to compact the name Why do we need compact name? Is just to avoid the delays caused by adding the names or deleting the names from PITs and FIDs, because it is the most challenging thing in ICN or in CCN, content-centric networks or information-centric networks. It's the most difficult thing. So our results, we simulated the initial results using the network simulator version 2, but we are planning to do that in 3 as well. Of course, then the results will be probably the same. And in these 2 graphs, we are showing that using the prefix or hash functions of the names, how much time it takes to add 100 entries as compared to the existing solutions. And the second graph shows how much time.
25 minutes or more.
Just finish.
Okay. So the conclusion is that we propose a naming scheme for vehicular information-centric networks that uniquely identifies by using the hash function. And you can just ask a question. This is just. Thank you.
Yeah, we have 2 questions maximum.
Thank you.
Yeah.
I have one question. Which are suitable performance metrics to evaluate your scheme? So how you can say that your scheme is better than the schemes that are available in literature?
The performance metrics we evaluated, or we just selected to evaluate our scheme, was adding and deletion of names in the PIT and FID, because the remaining schemes which are flat or hierarchical or others, they take a long delay to manage FIDs and PITs.
And do you have any preliminary evaluation of your proposal?
Yeah, these are the results. These are the results. Because